So welcome back. Now we're going to talk about file structure and data management using the specific case of the TIER, which stands for Teaching Integrated in Empirical Research, which is a protocol from Haverford College in the United States, and it provides you with an easiest way to build an efficient and reproducible workflow. So TIER is structured as follows. So it's just, as I said, a way for you to better organize your file, right? So assuming, for instance, you have this project of data science and you have a big folder that you call data science, and within that big folder you put the different subfolder. So you have this folder of original data. So the original data is just the KIHS, for instance, the KIHS file that each of you receive on a CSV format. So it can also be on an SPSS format or an Excel format, but just take the case of the KIHS project that you're currently working on. So here, then you're going to put your file in the original data. So the CSV file that you receive from Mati, you put that on the original data and you never change that, right? Like you never modify this data set. Is here. And then you have the document folder, and in the document folder you put the paper, the final paper that you're currently working on. You also put other document, for instance, what I would call the README file. So the README file is just a file describing what are the different files that are within each of these folders, and I will come back to that a little bit later. The command file is just the file containing the different do file that you're using in order to clean your original data set. So here you can already see that you don't actually mess the different files. So the command file or the do file is where you put the different do file or your do file that you're using to analyze the data. And then you have the analysis data containing the clean final data set that you have as the result of cleaning, importing, and doing everything in the command file, because you have different type of do file, and then as a result you have an output data set that you put in the analysis data set. Okay, so as I said, the original data contains the original data in CSV or in Excel, but also the metadata folder. The metadata folder is just like the questionnaire or any information that you might have that might help you to better understand your data, right? It can also be a report, the report of the KIHS, for instance, helping you to better understand your data and the origin of your data or how your data were collected. This is the first folder you have, the original data folder. Then you have the analysis data folder. As I said, it contains the clean data set ready for data analysis. So it's clean and you can analyze everything there, and then you get the result that you put on the paper. And then you analyze, you get this analysis data based on the command file. So you actually have the command file containing all the do file. So remember, first you have to import the data that you got from Mati. You import those data from Excel or from CSV to Stata, and then in Stata you started doing descriptive statistics, and then you did some probability, and then you did some hypothesis testing and perhaps some regressions. So all of those do files that you use are in the command file folder. So you don't mess the data and the do file. The do file is in a specific folder called the command file. And then you have the document. So as I said, the document folder contains the README file, which is describing what each of those folder contains. And you have the final paper or the report. And I forgot to mention the data appendices before. The data appendices is just like the descriptive statistics, for instance. It's not obliged to have a data appendix, but you can still have. The data appendix can also be some useful tables that you run that you don't necessarily want to put on the table on the final paper. So the data appendices are just like it's really like an appendix, right? It's like a data set result that are interesting, but that are not necessarily obliged to be in the final paper. So you have the choice to have a data appendix or no. So here I'm going to give you like a visual description of the TAIER protocol. So for instance, this is how the TAIER look like. I was just telling you have the analysis data, the command file, the document folder, and then the original data folder. So let's take a look at the original data folder. So here what you have the Excel. So this is just an example. This is like a homework that was given at Haverford College to students, and here within this folder you have the original data set coming from the World Development Indicators. So they have this, so you see that in the original data folder you have the original data set, and in your case, and as I will show in the example that you will certainly listen in data, that's the KIHS CSV or Excel data that you receive on your email that you don't have to touch. It has to be raw. You don't have to modify it in any way. And then the metadata folder, as I said, contains information about the report of your survey that you're writing the paper on, and also you have a metadata guides that are actually giving you information about what the data set is about, how it was collected, and so on and so forth. So that's it for the original data folder. And then you have a command file folder where you have the different do file that are summarizing the different steps that you take in order for you to analyze your data. So you have the do file for importing the data from Excel to Stata. You also have the do file for importing for processing the data, so analyzing the data, cleaning up the data, and then you have the do file for appendix, so doing some descriptive statistics, and then you have the do file for analysis, right? If you did some hypothesis testing or some probability or any other kind of statistical analysis, then it is in this do file. So but you don't need to have 4 or 5 do file. It depends on you and your task, right? And we will have a practical example during the tutorial tomorrow, but also in this data video that I'm going to upload. And then you have the analysis data. So in the analysis data, these are the data that are actually the result of your processing. So here you can see that in order for you to have a reproducible workflow, you actually have to never ever modify manually the original data by yourself, right? Like, you always have to use the do file to analyze or to clean up or to import anything in the original data. So if someone is taking your work, he only have to run the do file and move from the original data folder to the analysis data folder. And last but not least, you have the document folder where you have the readme file describing what is within each of your folder. You have the final paper, and then you have the data appendix. If you like, if there are some tables that are interesting, sorry for me, but cannot fit on the paper, then you can actually add that as well, right? So that was to show you the TAIER protocol. So let us go back. Now we're going to talk about the best practice for coding, right? Like, after you have those folder organization, you actually need to know that how the different do file, for instance the processing do file, you need to actually be able to consistently label your variable. So give some name that you can better understand, right? So most of the time you have names. Remember, for instance, in the KIHS you have name like XXF or TOTY, which can really not tell you anything clearly, right? But the name of the variable is like a code, but you should be able to label the variable so you can clearly see or clearly link the label in your data set with what is in the questionnaire. And this has to be understandable, because you can come a week later, remember the code that we use at the beginning, that you're not doing it for yourself but also for other people. So when they come and they would like to check your work, they can easily make the link, they can easily find themselves in your work. use, right? So use codes and label your different variable in such a way that you can understand if you come a week or a year later, but also other people. And you should also be able to make, as I was already saying, a clear link between the name that you're giving to the variable or the label that you're giving to the variable to the name of the variable in the questionnaire that you're using. And in Stata, for instance, I was giving the example, you have the TOTY variable in your KIHS file, which is like the total number of expenses, right? The total of expenses at the household level, or the amount of expenses at the household level. And then this is very important. You should be able to label your variable in such a way that it is understandable by other people, but by you a year later. You also have, as I was saying, you have like a consistent way of labeling the variable is very important. The different value that you give to your variable. For instance, you have the variable gender, so 0 male, 1 female. Don't just say 0 sex 1 or sex 2. So clearly say female or male, so someone can better understand. Okay, clearly understand. Someone completely external from your work can clearly understand what you mean by a specific value of a variable. For instance, here you have whether the person has any boys under 10 years old in the household, whether the head of the household has any boy under 10 years old. So maybe one, you cannot just say yes, but maybe you say yes, boy under 10, and then 0, no, boy under 10. So you clearly put the label in such a way that it's pretty much understandable. So again, you also have the issue of missing value in Stata. So usually you have missing value, and missing value are generally a dot for numerical value or double quote for strings. And it is very important for you to make sure that they are standardized in the data set, right? Because it can also happen that a missing value has been already taxed as a 999 during the codification in the household, in the survey house or the statistical office, and then you have the data set. So you should be able to know that for some variable the missing value can be different. For instance, if a variable only has like 2 decimal, or is just depending on the size of the variable, the way the missing value is represented can be different. So it's very important for you to be able to standardize the data set in such a way that you put the dot everywhere for each of the variable, but also clearly underline the rule that you use to consider a specific value in a data set as missing, right? So it's very, very important for you so that you can actually better work, but also you can make other people better understand what you did. So if they also want to come back and clean the data, they know exactly what you use as missing or what you consider as missing. I just took an example for the missing value. For instance, maybe you consider that any household that said they have an income of 2,000 billion euros, you just consider that missing because it's not a plausible value, and you consider maybe that's an error. So you always also have to remember that in Stata, all missing value are considered to be bigger than all non-missing value, right? So for instance, if you're recording a variable and you say record the variable sex equal to 1 if the former variable, if the variable gender is greater than 0, then greater than 0 means the dot, the missing, will be considered. So that's something very important when you're doing recodification of your variable. The missing value is always the bigger than all non-missing values. So you should always be able to say if not missing, right? I think we did some of those type of example in the tutorial before. Now, how do you write your do file? Always start your do file with your header. So when you start your do file, you always have to put your name, and including all of your contributor. And in the do file, you always have to precise the date of the creation and the date of the latest modification. Especially you have to precise what is the purpose of this particular do file, what does it do. The Stata version used to build the do file has a command, so use the command, the Stata command version, not as a command, so people can easily, when they run, they know exactly which version you use, right? So they might notice there are some discrepancy. For instance, between Stata 11 and Stata 14 there is a couple of differences, and there are some commands that are in Stata 13 that are not in Stata 10, for instance. So people should know and use user-friendly command in case you don't have that in like an older version of Stata. You also have to list the different input and output data set. For instance, you might have some do file that are using some data set before, and then they are processing that and then give you an output data set, so you should be able to list what the do file is doing, and you do that already in the header. Also, the set more of command is very useful. It's allow the do file to run uninterruptedly, so it has to be on the header. Log using always, so it creates the log file which capture all output from the resulting do file, and when you have the capture log closed before the log using any name you like to give to your log file, it prevents Stata to stop running if a log file is already open. So that's very important that you always put that on the header. And you always set your working directly. You can use fastcd. CD means change directory, or global, so you will see what global means later on. So again, writing your do file, you should be able, if you have a long do file, each different sections correspond to a specific task. So importing your CSV, importing from Excel, cleaning, recording, clearly commenting the different section is very important. So each of the section in your do file has to be organized, and you have to say what each of the section is doing. You always also have to comment your code, so always put some comment after a line, so you actually explain what the line is doing, what the command is doing, what you intend to do. That's very important, because as I said, your mind can play you some trick. I know sometimes we believe it's not necessary, but it's very important to do it for yourself, but for other people to replicate your work. For instance, I just took an example. You can comment, you can use marker, you can also comment for each specific task. For instance, creating or exporting a table, merging or appending, reshaping, you put exactly what you're doing, so you are able to replicate your work later on. You exactly put what each of the section of your do file is doing, and you write the expected result. What do you expect? For instance, if you merge two data sets, you expect what is the number of observations that you expect, and then you put that, so it's clear. The person already know, okay, between this step and this step you lose that number of observation. Or when you drop observation, for instance, you have to put the number of observation that were there before and the new number of observation, so the person can check what you lose in between the different steps. So I think I have to stop here, and then we'll resume afterward with the master do file. Welcome back. So now we're going to talk about master do file. So the master do file is the do file containing and running all the do file for a project. For instance, you might have a do file for importing your data, for cleaning your data, and for analyzing your data, like processing your data. And the main aim of the master do file is to run the different do file once and get your paper result directly, right? It's true, we're also going to look at dynamic document, where you can have not only the result but the whole paper, but the master do file is already giving you all the different tables, so you don't need to run the different do files separately, but you have a big do file, the master do file, running the different do files separately. And then in the master do file, if you have user written commands, which are commands that are not incorporated in Stata, you have to put that in the master do file. You have to precise that those commands were used in the input do file. And you also have to install those commands, otherwise the do file won't run, right? And then the header should be included in the master do file. Like, it's not because it's a master do file that you want also precise the set more of. You remember we talked about the header, capture lock close, lock using, so all those information also have to be on the master do file. The header information that you put on the input do file also have to be on the master do file. And you also have to put the number to actually put the number of your input do file in such a way that you know which specific input do file should run first. So you have to actually be able to say, for instance, this do file about importing is the first do file, is the first input do file. The other do file on data cleaning is the second do file, and the other do file on data analysis is the third do file. So you should be able to actually after having have a list of the input do file and the different numbers about which do file should come first, then you can actually know in the master do file what comes first, and then run your master do file and get the result. It's also very important to keep the raw data in the purest form possible. For instance, it means you should import directly into Stata in the form the data came in. For instance, you receive your KIHS dataset into a CSV format, so you should not change that in an Excel format before importing into Stata, and vice versa. So if you receive your raw data format into an Excel format, you should not go and change that to a CSV. So you have to keep the raw data in the purest form possible, and that's very important because you can alter it by changing the format of the original data in between. So it's very important to never ever touch the format, or never ever change the format that the raw data came in. Also, clean as much as possible within Stata, right? Like, even your master do file, you don't have to do anything manually. Do everything in the do file. Don't make one of changes to the original file manually. Never ever. Always have do files to process the data, to clean the original data set, to import the original data set using do file. Never ever do that manually. It's very important to ease the reproducibility and the replicability process of your report. So staying into the master do file, we have what we call relative references rather than absolute references. When talking about absolute references, it's about the path, right? It's like every time you open your do file, you have to set up a path, or you have to know in which working directory or path you're working on, and then you use the command pwd, print working directory, to be able to know which path you're working on. But if you want to set up a working directory, you can use the command cd or fastcd, cd for change directory, fastcd for fast changing directory, and that's very important. And you have to use globals. The globals are actually commands that are helping us to store information in the memory of Stata. And most of the time you use global when you want to set relative references for your master do file. You have to use global, and then you precise the path where you have your data set, where you have your do file. And then that's an example. For instance, here I'm having my link to my folder where I'm working on, and then I would say cd. So I am asking Stata to change the directory to this path or to this working directory, and then I can actually only say use the data, so I don't have to actually, before using the command use, to put the path before. It will be too long. So I'm first changing the directory, and then I can use everything within this directory. Another way of doing that, if you don't want to always if you want people to easily replicate your work or your final report, you can go for global. So global is actually as I said, a command helping you to store information into the memory of Stata. So the global, when you say global data, so it will create a path. So now Stata will know there is a path or there is a link to your working directory called data, and that's the link here. That's the link. And then you can use this and just quote this information before you call your main data set for analysis. That's very important. So this is an example of one master do file we have here. So in this master do file, as I said, you have the header, and then you always put in the header your name, the date of the creation of this do file, the content. So you give an overview, so you explain your project. So here you will say, for instance, this is like the final report of the introduction to data science and statistics, and then you have the different do file or the input do file that you have that will help you to compute your master do file. So for instance, you have the do file for descriptive statistics, you have the do file for importing your data, the do file for doing some probability, and then all those do files have to be listed here. And then you have globals. So the globals are, for instance, like the different pathway, or if you have any kind of anything that you like to store in the memory of Stata, and then you can just run those do files from the first one to the last one. So the first one can be the one that you use for importing your data set, and then the second do file is the one you use for, say, cleaning the data set, removing the missing value, and then the third do file is the one that you use, for instance, for doing some descriptive statistic analysis or probability analysis, and then the last do file is, for instance, the one you use to do some hypothesis testing. And then when you run everything in this master do file, you have your result coming on into the log file, and then you can just copy and paste the result into your final report file into the document folder, right? So that's how it works. And you need to make sure that all those do files are within your global path. So you just run everything, and if there is any input data set as well that each of those do files are using, they should be all has to be in this specific folder. So you just run everything at once. That's very important. Okay, so going back to where we were, sorry. So this is the example of the master do file that I was just telling, but this example is much more better because here is using our file structure that we show in the beginning. So you have the header, and then you have the different path that you're suggesting. So you have the global path. So global is a command that is helping you to store this path or this working directory or the link to your working directory into the folder, into the memory of Stata. And then this global, this path that you're precising, is where you have all the log file or the original data set, clean data set, and then the do file. And then you call the log file for the folder of the log file. You also give the path. You also have the path for the do file, so the different codes. You also have the path for the different data sets, so the original data set or the clean data set. And then you just run the different codes. So you run the analysis, so this is like pre-analysis, but this is like data cleaning. You run the different code or do file for each of the steps that you apply to the raw data. So you do for the analysis, and then you do for the cleaning, and then you do for the analysis. So you use the do commands to call the different input do file into your master do file for you to be able to get your result on a click rather than running each do file separately, right? And those do file are taken in the path where you're storing your do file. Remember, we have the command file in our Tailleur protocol folder. That's where Stata is going to take those input do file and run everything. That's very important for you to understand. So I think that's the end of the lecture. I hope you guys enjoy it, and I'm wishing you the best luck for your report, for your final report submission. And I'm also inviting you to listen to the video on Stata, how you can easily implement that in your work. Thank you so much. Bye.